All right, we're back, hopefully to finish this up. So this is number 28. So what we want to do is we want to write a congruence transformation that maps one figure to the other figure, and then we're also going to write a congruence statement for the two figures in each coordinate grid. Okay, so what I would do in this problem is I would first figure out, in order to map triangle ABC to triangle DEF in number 28, I would first figure out, is this a reflection, or is it a translation, or is it a rotation, or is it a combination? And if it's a combination, we're going to state what it is. A combination would mean that two of these movements are going on. So here you can see that I have traced triangle ABC, and don't worry about the stuff going on over here. This is going to be for another problem. And what I want to do is I want to figure out, how do I get that triangle to map exactly on top of that triangle? So first of all, let's just see if I could just rotate it onto the other triangle, and you can see that simply rotating is not going to work. Okay, and also simply just sliding it isn't going to work. So what that tells me is I am probably going to have to reflect this triangle. Okay, so first of all, let's go ahead and reflect it over the x-axis, and let's see what happens. So you can see when I flip it, I get that right there. Okay, that's a little bit hard to see because this triangle is hiding underneath it, but there it is. And you can see faintly that now the two triangles are perfectly lined up. So the first move that I did was I reflected this over the x-axis. So my first move was reflect over the x-axis. Okay, and then my second move is I'm going to have to slide this shape. So I'm going to slide it 1, 2, 3, 4, 5 to the right. Okay, and then that'll end up mapping right on top of the other triangle, and then translate 5 units right. Okay, so that is how we could do that. And if you want to write this in notation form, you'd say translate x plus 5, that means 5 units right, comma, y. Okay, so that's how we would do number 28. Number 29, we're going to map triangle ABC to triangle DEF. So here's ABC up here. You can see that I've already traced it, and there is my triangle there. And I want to move it so that it maps right on top of triangle DEF. And you can barely see DEF down there. Right there. Now, you still can't see it too well. Okay, so first thing we're going to do is I'm just going to rotate it. See if I could get this triangle to just rotate right on top of the other triangle, and you can tell I cannot do that. So a simple rotation will not work. Okay, so what am I going to have to do? Well, I'm probably going to, how about if I rotate it this way? Now, if you notice, when I rotate it that way, so that is I started right here, and I rotated it 90 degrees to the left, so I rotated it 90 degrees counterclockwise. You can see that I almost have it lined up. It's just opposite of the triangle that I'm trying to get it on top of. There's the triangle I'm getting on top of. It's faintly showing up if I press it down. Then if I flip the shape over, the two triangles end up on top of each other. Okay, so this is going to be a combination. And what I'm going to do is the first movement is that I rotated 90 degrees counterclockwise. And you could just say counter, you don't have to say counterclockwise. And then I did a reflection over the y-axis. Okay, over the y-axis. So that would be the movements that I would make in number 29. Number 30, I want to map triangle ABC to triangle FGH. Okay, and I've already done this one here, and here we have it right here. So you can see I've already traced triangle ABC. There's my A, there's my B, there's my C, and I'm just going to try to map it. So I'm just going to see if I could just simply just rotate it on top of the other shape, and it's not a simple rotation. So rotation isn't simply going to work. So the next thing that I'm going to do is I'm going to see, well, what happens if I flip it or if I reflect it? So I'm going to reflect it over the y-axis. And when I reflect it over the y-axis, it looks like that. Okay? And I don't know if that's really going to help me, but let's see if I reflect it now over the x-axis, then it's going to look like that. So a reflection isn't necessarily going to work either. All right? But maybe if I do this, maybe if I slide the shape down to here, maybe, I don't know, to right there, and then I reflect it, then I get that shape right there. Okay, so the first thing that I could do is I could reflect it, and then if I rotate it 90 degrees, I'm not going to get it either. So number 30 is a tough one right here. So let's try rotating it this way. No, that wouldn't work. Let's try rotating it this way. Alright, and then let's try reflecting it over. No, that's not going to work here. Okay, so, my gosh, I'm a little stumped right now. So I need to get it to fit like that. So this is what I need to do. So I need to get it to go from there to there. So my first move is I actually I think I'm going to have to rotate it first. And the only way that I can rotate it is to rotate it that degrees. Well, let's go ahead and skip number 30. It's not a good problem because I think you're going to have to rotate it 45 degrees. Okay, the next one, the last one, hopefully this one goes better. I'm going to take this triangle here, DEF, and I'm going to rotate, or I'm going to map it onto the other triangle. Okay, so if I just simply rotate it, you can see it's not going to work to get it to go onto the other triangle. Okay, so let's try flipping it over the y-axis, which would get me to there. And then let's try flipping it over the x-axis, which would get me to there. So that's not going to work either. So let's try flipping it over the x-axis first, which would get me to that shape. And then maybe if I then rotate it around, it's going to get me to that shape right there. Okay. So I need to get it, let's see, how can we get it to fit? So we wanted to get it to go like that. So we're going to have to do, so what we're going to have to do is we're going to have to rotate the shape so that it's lined up. Let's see, how are we going to get it to line up first of all? Okay, so we've got that there. Okay, so we're trying to get this shape to end up on top of the other shape perfectly. Like that. Okay, so we're going to have to get the shape to rotate so that F is on top there. So the first thing we're going to have to do is we're going to have to rotate it 90 degrees, and then we're going to have to slide it. 1 to the right and 1, 2, 3 down. Okay, so once again, we're starting here. I know it's not the easiest thing to see, but we're going to rotate it 90 degrees counterclockwise, and then we're going to translate the shape 1 to the right, and then 1, 2, 3 units down. Okay, so this is going to be a combination. We're going to do rotate 90 degrees counterclockwise, and you don't have to write counterclockwise, you could just write counter, and then we're going to translate 1 unit right, 3 units down. Okay, so that would be how would you go about doing number 31. All right, moving on to number 32. We're going to solve for x. Make sure you can see it, and then we're going to solve for y. So you notice in number 32, we know that those two sides are equal to each other. Okay, so this is an isosceles triangle. That would make those two sides the legs. Remember, the legs are the equal sides in an isosceles triangle. This would mean that this side, A to C, is the base. Now remember, the two angles that run along the base are always equal to each other. So those two angles are equal to each other. So that means that x in number 32 has to be equal to 50. Okay, and then to find y, all I have to do is I have to take that 50, so that angle is now 50, add it to that 50, so 50 plus 50 is 100, and then subtract it from 180, because the three angles in a triangle add up to 180. So in number 32, y is going to be 80 degrees, x is going to be 50. Okay, in number 33, what you should notice right away is that this angle is equal to that angle, which is equal to that angle, so all the angles are equal. So that makes this triangle an equiangular triangle. Okay, now if you recall from the notes we took, if a triangle is equiangular, it means that it is also equilateral. So that means all of these sides are equal. So that means if I wanted to solve for x, I would take the 2x minus 5 side, and I could make it equal to either one of these two sides. And I would want to make it equal to the 8 side, not the y. I think that's a plus 3 side. Okay, and then I would solve this equation for x. Add 5 to both sides. 2x would be equal to 13. Divide both sides by 2. So x would be equal to 6.5. Okay, to find y, we would do the same way. I'm going to assume that is a y plus 3. So I would take the y plus 3 side, and I would also make it equal to the 8 side because all the sides are equal. And I would subtract 3 from both sides, so therefore y would be equal to 5. Okay, so there's number 33. Number 34, we're finding x and y. Now if you notice, we have a triangle right here, and then we have a 115 degree angle outside the triangle. So the first move that you would want to make is to find this angle right here, which is right next to the 115 degree angle. Notice they're adjacent to each other, and they're on a straight line. So that means these two angles add up to 180. So if I take 180 and I subtract 115 from it, that tells me that this angle is 65. Okay, degrees. Now, this triangle right here is an isosceles triangle, is indicated by the two equal sides. So that means both of these sides are my legs and the bottom side is my base. So the angles that run along the base are called the base angles, and they're equal. Therefore, in number 34, x is going to be equal to 65 degrees. Okay, so I can put a 65 here. Now to find the value of y, I just add up the 65 and the 65. That would give me 130. And then I subtract 130 from 180. And that would give me my answer for, there we go, we got the lights back on, for 50. For y. So y would be equal to 50 degrees. Okay, so there would be number 34. Turning it over to the last page, number 35. So in 35, we know that we have three sides of a triangle that are given. We know that one angle is 42, the other angle is 69. So the first thing I want to do is I want to find this missing angle right here. So 69 plus 42 is 111. 180, subtract 111 from that, that gives me 69. So that missing angle is 69 degrees. So that means I have two equal angles in my triangle. So this is an isosceles triangle. So that means this side is the base, because the two equal angles called the base angles run along the base, and then the other two sides are the legs. Okay, and remember, the legs are the two congruent sides of an isosceles triangle. So I could use that fact to make the 5x minus 2 leg equal to the 2x plus 25 leg, and I could use that equation in order to solve out for x, which is what I'm trying to find. So I would subtract 2 x's from both sides. That would cancel out the 2 x's. My equation would become 3x minus 2 is equal to 25. I would add 2 to both sides. That would cancel out the 2's. My new equation would be 3x is equal to 27. I would divide both sides by 3, so x would be equal to 9, number 35. In number 36, we're going to do the same idea as we did in number 35. If you notice, I have two equal angles here. And so those two equal angles would be the base angles, which would make the 3x minus 1 side the base. Which means that the 5x plus 2 side is a leg, and the 7x minus 4 side is also a leg. And remember, the legs are the equal sides in an isosceles triangle. So therefore, that leg, which is represented by 7x minus 4, is going to be equal to the other leg, which is represented by 5x plus 2, and then I use that equation to solve for x. Subtract 5x from both sides. 5x's cancel. I get 2x minus 4 is equal to 2. Add 4 to both sides. The 4's would cancel. I now get 2x is equal to 6. Divide both sides by 2. X is going to be equal to 3 in number 36. Okay, number 37 says, what is the measure of the base angles? Okay, so if you notice, we have two sides that are equal. So that side is a leg, that side is a leg, which means that the side that's marked 20 is the base, which means that the two angles that run along the base are the base angles and they are equal. So to find that, you're just going to take 180, subtract 50 from it. That's 130, and then since both of those angles are the same, you're going to divide by 2. So the answer is 65 degrees in number 37. Both of those angles would be 65. Okay, number 38, we want to find the value of x. And if you notice in number 38, we are given that this angle is 72, this angle is 36, and then we have values on each side. So I want to see what this angle is first. Okay, so I'm going to add up 72 and 36. That adds up to 108. Then I'm going to subtract the 108 from 180 because the three angles in a triangle add up to 180, and that's 72. So you can see that we have a triangle that has two equal angles. So that means this is an isosceles triangle. Two equal angles, those are my base angles. The base angles run along the base, so that side right there, 5x minus 1 side's the base. So the other two sides are your legs. And remember, the legs are the two sides that are equal to each other. So that means to find x, I'm going to take this leg, which is represented by 4x minus 2. I'm going to make it equal to the other leg, which is represented by 3x plus 5. There's my equation. And now I use algebra in order to solve for my x. Subtract 3 x's. I get 4x minus 3x, that's just x. Minus 2 is equal to 5. Add 2 to both sides. And in number 38, we get x is equal to 7. Number 39 says find the value of x. So what I'm going to do is, I notice right away that I have two equal sides right here. So once again, if you have two equal sides, that's called an isosceles triangle. The two equal sides are called legs. The third side is called the base. And the two angles that run along the base are equal to each other. They're the base angles. So to find the value of x, it's going to be the same as that value. I'm just going to take 180. I'm going to subtract the 68 degrees from it. That gives me 112. And then I'm going to divide both that by 2. So that gives me an answer of 56. So that means in number 39, both of those angles are 56. So x is equal to 56 degrees. Okay, number 40, the final question. I'm going to be finding the value of x. And I am given values for these three sides. And I'm given one angle is 58, the other angle is 64. So my first move is to find this missing angle, to see what kind of triangle I'm working with. So I add up 58 and 64. That gives me 122. Then I subtract 122 from 180, and that gives me 58. So that tells me that this missing angle here is 58 degrees, okay? So notice we have two equal angles. So these angles, which are equal, are my base angles. The base angles run along the base, so the 6x minus 10 side is the base. And then the other two sides are the legs. And the legs are the two sides that are equal to each other. So to find the value of x, I take this leg, which is 4x, represented by 4x plus 12. I make it equal to the other leg, which is represented by 3x plus 5. And then I solve that equation out for x, and that would give me my answer. Subtract 3x's from both sides. 4x minus 3x. Those 3x's will cancel out. 4x minus 3x is 1x. I could just write x. Plus 12 is equal to 5. I subtract 12 from both sides of the equation. And I get x is equal to -7. Okay? So that would be how you do those problems right there. Alrighty?